So does that make sense? Okay. And you can see right out of the gate, we've got better numbers to work with than those decimals. And we don't even have to factor anything out. Again, before I finish this and do this problem for you, everybody, I want to stress as well that when you're solving a quadratic equation, after today, you will never use completing the square again to solve a quadratic equation. You will use completing the square to determine the coordinates of the vertex of a quadratic function. You still need to know how to do that. But in terms of solving an equation, what we always want to do is try to make it easier. In this case, that just means dividing that negative 0.1 out. Now I can go ahead and get started on completing the square. I need to add some number. The nice thing about this, by the way, is once I decide that that number that I'm going to add is 9, since I didn't have anything that was factored out, I can just say minus 9 and almost be done. Well, not quite, but now I can write x plus 3 quantity squared is equal to, well, I kind of did two steps at once there, didn't I? But you're fine with that, I take it. Negative 9 plus negative 4 is negative 13. I move it over, I get 13. So then I can say x plus 3 equals plus or minus root 13, which means x equals negative 3 plus or minus root 13. And what I suspect would happen if you did this by factoring out the negative 1 is you would have more work to do to clean up your answer. Anyway, is that helpful? Okay. Any other questions anybody would like me to do? Right. So we're moving on today, and we are looking at solving quadratic equations by using the quadratic formula, which brings me to the point of your unit exam. This is the second to last lesson of the unit, which means we will finish the unit Monday by covering the final lesson. Tuesday and Wednesday of next week will be spent reviewing, so the Thursday before our 4-day long weekend is the day of our exam, which works out nice. Then you can go home, have a nice 4-day long weekend and not have to worry about math. We've learned that you can solve quadratic equations by graphing, which is a non-algebraic approach. That's what you would do if you just wanted to be lazy or you just want to get an answer really quickly. Or maybe that's the only thing you can do. I hope that's not the case. We've learned, in addition to solving by graphing, you can solve some quadratic equations by factoring. You cannot solve all quadratic equations by graphing, by the way, unless you're okay with decimals. Like, let that sink in. You cannot get exact values all the time by looking at the graph. You cannot solve quadratic equations by factoring unless they're factorable. You can solve any quadratic equation by completing the square, and you can always get an exact value. But let's face it, completing the square is a real pain in the butt. It is. It's annoying. The fourth method is using the quadratic formula, which is what we're going to learn today. And I will warn you right now that the warm-up is not intended to be something that you could do on your own, even after seeing it. Okay? It's not intended to be something that at the end of this warm-up you go, oh yeah, okay, now I know how to do that. It's intended for two reasons. Because we need it to come up with the quadratic formula. We need to understand what I'm about to show you and what we're going to do to get this fourth approach. And I'm doing it to model algebra skills. Many of you, most of you, I hope, will go on to Math 30-1. Many of you will go on to calculus. Many of you will go on to post-secondary. We're building these skills for later. So when you ask your math teacher at this level, why are we doing this? Sometimes there's a reason. that it's a good application. But sometimes the reason is because it makes you a better math student. So you can do higher level math later. So look at what we're asked to do here. We're asked to complete the square of a quadratic expression. It's not a function, it's not an equation, it's just an expression. But there's no numbers where there should be numbers. But we can, if we want, and I don't know that you need to write this down, but if I said to you, complete the square of 2x squared plus 20x plus 1, what is the first thing that you would do? Well, you would take the 2 out of the x squared and the 20x, wouldn't you? That would be the first thing you would do. You would take that number 1 and you'd kind of nudge it out of the way, and then you'd factor the rest. But you have to ensure, and I had a conversation with a couple of you yesterday and at lunch or before lunch today, you have to ensure that that number is a 1, right? Before you proceed. But this number up here, and I want to rewrite this, it's ax squared plus bx plus c. This number is not 1, so we have to factor it out. But we're going to nudge this c out of the way. So what I have on the right, everybody, is simply what we would do if we had numbers so that we can decide what to do if we don't have numbers. So where did I get the 10 from? Well, it's very easy to say, well, I got it because when I factor 2 out of 20, I get 10. But mathematically, to get the 10, I take the 20 and I divide by the 2. So what I'm going to have left will be x squared, and then my x term is going to contain b over a as a coefficient. Because I have to take the old coefficient and divide by the thing I factored out. And if you wanted to right now, I don't think this is, bless you, I don't think this is really necessary for you to write down. But if you wanted to, you could see that if I multiply this through, I get ax squared plus bx, don't I? Because the a's will cancel. And then this is where we add something here. What do we add? Well, let's go over here to the right-hand side as an example. What do we add? We add 25. And I want everybody to roll that around upstairs. Think about it, in other words, for a second. And see if you can figure out where the 25 comes from. I hope you can, because you need to know how to do this. It's half of 10 and then squared. So what do we put, if we take half of 10 and square it, and that goes there, then over here we have to take half of b over a and square it. And rather than writing b over a divided by 2, which would be problematic in terms of fractions, let's just write 1/2 times b over a. So what is that? 1/2 times b is b, 1 times b is b, and we have to square it. And then on the bottom of this fraction, we have 2a, and we have to square it. In other words, I'm squaring everything in the brackets. I'm squaring the b, I'm squaring the 2, I'm squaring the a. So I have to add b squared over 4a squared. Okay. What do I take away? Well, over here, what would I take away? Who can tell me what I would take away on the right-hand side? No. 50. We multiply those two, right? We've already done the factoring. We've already done the division. So what you have to do, getting a little crowded, so I'll just move this out of the way a bit, is you have to multiply this 2 by this 25 to get 50, and that's what we take away. So that means over here, we have to multiply, and I think I can erase this. We have to multiply this a by this b squared over 4a squared And that is what we have to take away. So what happens here is you have a on the top and you have over a squared, so one of those a's cancels. And we're left with b squared over 4a, which we have to take away. The next step would be where we write this in completed square form, where we do this, and then we have a single number over here. So, when, for example, when I look at the right-hand side, I'm going to end up writing 2 times something squared, and I'm going to put minus 49, right? Do you see where the negative 49 comes from? Well, that means we have to bring these two things together. So I'm subtracting two fractions, and I would recommend, and you have enough room here, I would recommend we take that c minus b squared over 4a, and we do that on scrap paper someplace, just off on the side. Let's bring this together. We need a common denominator. The common denominator is going to be 4a. So I'm going to have to multiply the top and the bottom of this expression by 4a. And the numerator is going to become 4ac, and this is minus b squared. So when we put these two together, they're all over 4a, and it's 4ac minus b squared. I want to reinforce to you that what we're doing here is very complex. And if you feel some sense of anxiety about the difficulty here, don't. It's not something you need to know how to do on your own. But at some point, many of you are going to have to be able to do this kind of algebra. And that's not how we learn math. We don't learn math by saving it all up for when you need it, and then all of a sudden you got to figure it out. That's no good. Okay? You have to learn to crawl before you can walk, so to speak. What else do we have? Well, we have this thing in brackets. What would we have here? We would have x plus 5, because 5 is half of 10, which would mean what we have over here is x plus whatever half of b over a is. Well, half of b over a is b over 2a. So that's the completed square form of a times x squared plus b times x plus c. This is our answer to warm up A or warm up 1 or whatever this is called. This is the same as ax squared plus bx plus c. If you were to expand that out on the left and simplify it, believe it or not, you would get ax squared plus bx plus c. So far, so what, right? Well, we're leading someplace here, and you will recognize the result that we get. The second part of the warm-up says, use this result, and I'm going to rewrite it down here just to make sure I have it right. Correct? So we want to use the result to solve this equation. But this thing, and I've been asking my classes today just because it's a habit I've picked up, and I hope it's helpful. When I highlight, it's not confusing to you, is it? It's helping connect the pieces? Okay. This is this, right? We've completed the square of ax squared plus bx plus c and got this expression. So if we're asked to solve ax squared plus bx plus c equals 0, then I guess we're asked to solve this. And that would be like us solving 2 times x plus 5 squared minus 49 equals 0. If you've been writing this down, this is what the completed square form of my numerical example would have been. And this is really simple, everybody. You know what to do here. You get rid of the 49, then you get rid of the 2 in front, then you take the plus or minus square root, and then you subtract 5. So the first thing you would do, I'm not going to actually do that, but the first thing you would do in solving that is you would take this number that's outside of the brackets and move it to the other side. So what's going to happen is we're going to get this. And I hope that everybody remembers the location of this negative is in the place that I dislike. I don't like having it right in the middle. I like it better in the middle than putting it on the bottom, but where do I prefer to have it? On the top. So why don't we do that? Why don't we take that negative, which is really on the top, and multiply it through the top to get rid of the negative? So I'm not doing anything else in terms of rearranging here. All I'm doing is I'm taking this negative, and I'm multiplying that negative into this. And when I do that, I'll have 4a on the bottom. The 4ac becomes negative. And the b squared becomes positive. Well, that's interesting. There's our old friend b squared minus 4ac. So this is where we are at. We've moved that thing to the other side. Now what I want to do is divide both sides by a. If I were solving this little equation in the top right corner of your screen, I've moved the 49 over. Now I would have to divide both sides by 2, the coefficient out in front. So I'm going to divide both sides by a. When I divide this side by a, when I divide this side by a, and I divide this side by a, what happens over here is these cancel, and I'm left with x plus b over 2a, quantity squared equals b squared minus 4ac over 4a squared. Sometimes I just breeze past this idea, and I think it's a mistake because I don't think you're really told this very often. When you divide a fraction by a thing, like a, it's the exact same as doing that. If I divide by a, I'm multiplying by 1 over a. And that's why on the bottom we went from having 4a to having 4a squared. Now I take the square root. And again, remember, I'm actually treating you right now like Math 30 and 31 students. So we're learning some tough algebra. If it's very confusing to you, don't sweat it. But it's at this point in time you would go plus or minus the square root. So we would get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. By the way, when I say I'm treating you like Math 30-1 students and 31 students, I'm not saying that I don't expect anybody in the room to follow this. I would expect most of you can follow this, but I know that some of you are going to be a little anxious about it. Now, do you remember doing this with completing the square? And we can do it over here if you like. I am going to actually do a couple of steps with this. I would end up with, no, I won't do it there. Do you remember doing this? And at this stage of the game, very often you would end up with a number like I'm going to go 205. You would end up with a number like that, where the bottom was a perfect square. And we would end up having to write plus or minus root 205 over 4 because we could take the square root of 16, right? Well, look at the bottom of this fraction that we're at. It's 4a squared. What's the square root of 4a squared? 2a. So I can simplify this a little bit and write x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. And then you would have to move that b over 2a to the other side, and we end up with x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. How many of you remember when you were completing the square that very often you ended up with a common denominator at this point? We do here as well. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is brilliant because you know what this is? You know what we've just done? We've solved every quadratic equation that ever is or ever will be written down. We didn't have numbers for a, b, and c. We left it as a, b, and c. If I give you any quadratic equation, if you know, I don't know why I wrote my x that way, the value of a, b, and c, you just have to put it into here and you will get the answer to the question. You will get the solutions. It's the solution to an infinite number of quadratic equations. So the result is called the quadratic formula. And let's just write it down here in your notes at the bottom. The quadratic formula is that if ax squared plus bx plus c equals 0, then x can always be found by doing this. It is the master key to every lock in the universe. It opens every lock, quadratically speaking. If you were to look at the front page of your handout, I'll just bring it up here. I mean, you may not be as amazed as the little baby is, but it's an amazing formula. It can be used to solve any quadratic equation. And this is called the quadratic formula. It's not called the quadratic equation, it's called the quadratic formula. It's a key. So now let's use it. Solve this. I don't care if it's factorable. I don't care if the solutions are rational or irrational. It doesn't matter. I can use this formula. And this is the way I teach it, everybody. And I'm not saying that my way is always the best, but I've been doing this a long time and it serves my students best, I think. There are three things you need to put into the quadratic formula. They are these three things. I think that if you put in A, B, and C and you put in all the numbers in the formula, it gets confusing. So here's what I would do. I would say, well, x is equal to negative b. So I look over here and I see b is 2, so negative b is negative 2. Plus or minus the square root of b squared minus 4ac. So I recommend calculating b squared minus 4ac off on the side somewhere. I know that many of you will just do it right on your calculator, but I want to point out that you should show that work on a written response. Okay, you don't have to right now. I'm going to. B squared minus 4ac will be 2 squared minus 4 times 1 times negative 1. And you've heard me say it enough, but I will say it one more time. When you substitute numbers in, always put them in brackets. So we calculate what this is, and this is 8. So, negative 2 plus or minus the square root of 8, all over 2a. Well, a is 1, so 2 times a is 2. And now I have to explain the rule for canceling. If there's one thing that I find students in grade 12 are lacking sometimes, is they feel as though they can just cancel things whenever they see identical things. Am I allowed to do this? Well, no, but I can tell by the reaction on some of your faces that some of you are not sure. And it's because maybe nobody has actually taught you when you're allowed to cancel. Because we just get into teaching mode and we go, oh, we cancel this and this. Well, why? First of all, I want to demonstrate to you that you cannot cancel it. I want you to calculate what negative 2 plus the square root of 8 all divided by 2 is. So I'm just on the side here saying, what is negative 2 plus root 8 all over 2 actually equal to? And when I do this on my calculator, I don't do it in one shot. I go negative 2 plus root 8, I hit equals, then I go divided by 2 and hit equals. It's this number, okay? So first of all, let me convince you that you cannot just say, well, I'm going to cancel this and get negative 1 plus or minus root 8. What is negative 1 plus root 8? Well, it's not that. I can guarantee you that, because root 8 is like 2 point something. Negative 1 plus root 8 is this number. So if it doesn't work for this particular set of numbers, then it's not something we can rely on. It doesn't work all the time. In other words, it's wrong to cancel that way. So when are we allowed to cancel? This is maybe the most important lesson today, other than the quadratic formula. You are allowed to cancel if you cancel a factor of the top and the bottom. Whatever you cross off has to be a factor of the top and a factor of the bottom. What are factors? Factors are things that are multiplied together. So if I have an expression and I have A times B times C, these are all factors. And this lesson that I've delved into right now is absolutely crucial to a huge unit later in this unit. So if I had A, B, C over B, D, am I allowed to cancel the B's? Yes, because the B on the bottom is being multiplied by the C, and the B on the top is being multiplied by the other stuff. I'm allowed to do that. Really important. Maybe the most important thing, math skill-wise, that I've talked about this year. Am I allowed to cancel the b's here? No, because that b on the top is not a factor of the top. It's not being multiplied by everything else. And I can see some of you going, oh, that you thought maybe you could, but now you see why you can. So, for example, another example, if I gave you x squared plus x plus 2 over x plus 2, I'm sorry, there's nothing you can cancel there. There is, on the top of this, only one factor. Now, if this were this, can I cancel anything? No. But the top does factor into x plus 2, x plus 1, doesn't it? Just give that some thought. Can I cancel something now? Yes, because now I have a factor of x plus 2 over x plus 2. So the golden rule is this. Before you cancel, you must factor. Okay? Now, we're not done. I cannot factor the top. There's nothing I can factor out of the top. But, and this again, I've mentioned this before, the math starts to pile up. Can you simplify root 8? You can. You can write it as root 4, root 2. Or, I hope you're okay with that, but many of you want to write root 2, 2, 2. You want to write 2 times 2 times 2 and take out a pair of 2's. But root 8, is 2 root 2. Oh, okay, well, just a second here. Let me put that in. X equals negative 2 plus or minus 2 root 2 all over 2. Can I cancel this 2 with this 2? No, because it's not, the 2 on the top that I've drawn the line through is not being multiplied by everything else. But what did I tell you the rule is? Factor, then cancel. Factor, then cancel. Factor, then cancel. This big unit that's coming up, and I've shown this to you before, this big unit that's coming up where we have to do all of this, guess what step 1 is of every single question in the unit? Factor. You cannot do anything until you factor first. So, can I factor the top? Yes, there's a common factor of 2. This is like having, everybody, negative 2 plus or minus 2a. I can factor a 2 out of that. So I factor a 2 out and have negative 1 plus or minus root 2 over 2. Can I cancel these two 2's? Yes, because the 2 on the top is now being multiplied by the rest, which means the 2 on the top is a factor. The 2 on the bottom, well, you have to use a bit of common sense. The 2 on the bottom is not really being multiplied by the rest, but it's still a factor because it is the rest. If you wanted to, you could do this, right? And say, I'm going to cancel it. So before you go cancel crazy with the result of the quadratic formula, factor first. Our answer then is that x equals negative 1 plus or minus root 2. So if you were to find the x-intercepts of the corresponding function, they would be these numbers. Negative 1 plus root 2. And negative 1 minus root 2. Those would be the two x-intercepts. Those would be the solutions you would get if, for some reason, you decided, I want to complete the square of this equation. But really, other than my big detour about canceling, look at the left side of your screen. That's the work. Next to nothing. Okay, let's try another one. 4 times x squared equals 3x, 3 times 4x plus 5. I guess we better simplify this first. So we get 4x squared equals 12x plus 15. Well, it's quadratic. I can see it's quadratic because there's an x squared, so I zero the equation. By subtracting those two terms to the other side. Again, everybody, and don't forget your equals 0. That is important. We have 3 things that we have to throw into the quadratic formula. One is negative b, one is b squared minus 4ac, and the other is 2a. All of the other stuff is just symbols. I mean, they mean things. So that means that x equals negative b, and just watch up here for a second. If b is negative 12, negative b is positive 12. That's all we do. We just switch the sign. Plus or minus the square root. I'm not going to show my work for this because we're in teaching, learning mode. We're not in writing a written response mode. But I want you to calculate b squared minus 4ac. I may write it down in a second, but I want you to calculate it on your own first. I get 384. Okay. I'm going under the assumption here that and we've talked about this many times, you have to square the negative 12, right? So the negative has to be squared as well. And then all these little things are just, I had a conversation with a Math 30-1 student this morning. This student is very frustrated because they feel they understand the Math 30, but they're getting poor marks on exams because they're making grade 9 and 10 mistakes, which is, it's a shame. You don't want to have to worry about that. So that's why I digress and talk about all this stuff. So it's plus or minus root 384 all over 2a, which is 8. Can I reduce the 12 with the 8? By the way, when you reduce a fraction, you're canceling. Can I cancel, say, a 4 out of the 12 and the 8? No, because 4 is not a factor of the top. I don't see a 4 times something. We have to start, everybody, by figuring out if there's a simpler way to write root 384. How many of you, yeah, we're okay for time. How many of you, when you simplify these radicals, prefer to write all of the prime factors of the number? In other words, you would say 384 is 2 times 192. Is my math right there, by the way? It is. And then you would go, let's see, that's 2 times 2 times 96. I don't like this. I'm not trying to persuade you to use a particular method. And then 96 is maybe 6 times 16. I'm getting bored of 2's. I think 6 times 16 is 96. And that means, I'll pick up the pace here. It's 2 times 2 times 2 times 3. 16 is 4 times 4, which is 2 times 2 times 2 times 2. How many of you remember doing this last year? And then what you do is you say, there's a pair of 2's, there's a pair of 2's, there's a pair of 2's. So I'm taking out a 2 times a 2 times a 2. And I have left this 2 and this 3. So it's 8 root 6. Remember doing that? How many of you, so I'm asking, how many of you would prefer to do it that way? I don't think there's too many people at this stage. So what I would do, this would be my thinking, is I would take my calculator and I would try to find a number that divides into 384 that's a perfect square. But I want to find the biggest number. So for example, if you say, I think 4 does, is there another factor that goes into 96 that's a perfect square? Well, 4 does and 16 does. I don't want to spend too much time today with this, but you do need to be able to figure out. Is that right? No. Yeah, 64 times 6. You do need to be able to figure out in one way or another, everyone, that this is 12 plus or minus 8 root 384 all over 8. You need to be able to bring this 384 or the root 384 into 8 root 6. One final point about this, and it's, again, the fact that I'm spending as much time on this as I am tells you it's important. If you think it's 4, then you would take 4 divided into 384 and you would get this. Are you with me? Okay. But then before you go on, you'd say, gee, I wonder if I can go a little deeper. Is there a number that goes into 96 that's a perfect square? And you might say, oh, 4 does. I think 24 times. So then you would say, I've got my 2, I've got a 4, and 24. So you would then say that this 2 times this 2 times root 24 is what it is. But then you'd go deeper. You'd say, can I do that again with 24? And eventually you would get there. So anyway, here's where we're at. Bottom right-hand side of the screen. Can I cancel those 8s? No, I can't, because that 8 on the top is not in brackets times everything else. So what do you do first? You factor. Is there something I can factor out of the top? Well, yeah. I can factor a 4 out of the top. And be left with 3 plus 2. And I made a horrible blunder there in what I wrote, didn't I? Will, what should I have written instead of 384? 6, thank you. Apologize for that. Bless you. So when I take a 2 out of 8 root 6, I'm left with 2 root 6 over 8. Can I reduce the 4 and the 8? Quite frankly, I'm glad some of you are kind of shaking your head because you're a little gun shy, meaning you're a little apprehensive about doing it. I can. And the reason I can is because I can write the 4 in brackets, and the 8 can be written as 4 times 2. So I can cancel the 4's there. So our answer is 3 plus or minus 2 root 6 all over 2. Oh, can I cancel the 2's? No. Now there's a shortcut here. It's only valid in this case. Can I cancel, here's my answer. From here, can I cancel a 4 out of the 12 on the top and the 8 on the bottom? No. Can I cancel a 4 out of the 8 on the top and the 8 on the bottom? No. But can I cancel a 4 out of all 3? Yes. So I don't need to take the 4 out. I could just say I'm going to divide this by 4 and get 3, this term by 4 and get 2 root 6, this term by 4 and get 2. Yeah.
Could you then go 3 divided by 2 and say
Yes. You can break that up now. You can say that this is 3 over 2 plus or minus 2 root 6 over 2 and cancel those two 2's. But what we would prefer, and this really becomes more important the higher up you get in math, what we would always prefer is one fraction as opposed to two. It's not wrong. Okay, let's try a couple more. We're going to spend less time on the simplification here. Hopefully you're getting the hang of this. This is 3x squared plus 5x minus 1 equals 0. So we are going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I would like you to fill in all of those shapes. Have a good weekend. Okay. Yeah. I mean, I think the only thing that requires any kind of concerted level of thought is the b squared minus 4ac thing, where you might want to grab your calculator. That's it. We're done. That's it. Those are the solutions. There's nothing to cancel. Because first of all, in order for me to cancel something, I would have to take that 37 and remove numbers from it so that they're outside, which can be factored out. 37 is a prime number. It can't be written as a perfect square times something. So we're done. And D, I think the last one. This is what I was talking about with the question that you had asked about earlier, that I have a negative out in front. And there is nothing wrong with you saying A is negative 1, B is 5, and C is 100. But I don't know why it is. Maybe it's because 99.9% of the time A is positive, so we get used to the patterns that emerge from that. So when it becomes negative, it throws us off kilter. Like we're nice and balanced and we see that negative and it messes with us a bit. So my suggestion is not to do this, but to do x squared minus 5x minus 100 equals 0. And there are all kinds of ways why I can justify that's what I got. I can say, for example, I've moved everything to the other side, where all of the terms switch signs. I can say, for example, that no, I'm going to multiply both sides of the equation by negative 1, or divide both sides by negative 1. But keep in mind, we're only allowed to do that because it's equal to 0. If it were equal to y, you couldn't do that. You can't just, if I have a function that says y equals, I can't just change all the signs, because then it's a different function. So we're going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is 2. I'm just curious before we go on, how many of you see that no matter what, you will not be able to cancel anything in this question? Because that 5, even if I can extract the 2 from that square root, that 5 is not an even number, so there's no way I can factor a 2 out to cancel. So all that remains is, can we find b squared minus 4ac? And if we can, well, we better be able to. If we can then simplify it further by extracting a perfect square. So b squared minus 4ac, 425. Well, 425 is definitely a number that we can extract a perfect square from. So we kind of go, I don't want to say scrap paper, because if this is a written response, you should be showing this work. But I don't think I would do what I'm about to do right here in this expression. You could. What I would do is I would say, well, man, that's pretty easy. 25 has got to divide into 425, because it's 400, which is divisible by 25, plus 25. I want to say 17. So 25 times 17 is 425. That means it's 5 root 17. And I would encourage you to do it this way rather than a factor tree. In the next unit, we will have to use a factor tree for certain things, but in this unit, we don't have to. So our answer is x equals 5 plus or minus 5 root 17 all over 2. And we're done. If you want to know what those values are in decimal form, you would go 5 plus the 5 square root 17 equals divided by 2, and then 5 minus 5 root 17 divided by 2. Any questions with that final example? Okay. So the assignment I'm going to hand out, I was going to say, oh no, I'll give it to you Monday because a lot of people aren't here. Too bad. If they're not here, then they'll have to work extra quick next week, because this assignment is due Tuesday. Okay. What this assignment is, I'll just show it to you, and then I will hand it out while you guys are getting started. Come on. There we go. You didn't get a Unit 3 assignment, and that's because the assignment I'm giving you covers Unit 3 and Unit 4. There we go. So they're all different, but what you will be given is a quadratic function. There's a quadratic function. You have to determine the coordinates of the vertex of the graph, the equation of the x-intercept. So you got to complete the square of the function. Then you have to determine the x-intercepts. How do you determine x-intercepts? You make y equal to 0 and solve that quadratic equation. But I want exact values. I want it done algebraically. And prior to today, that would mean completing the square, but now you can solve this using your friendly neighborhood quadratic formula. Okay, so this is due Tuesday. That way you can get it back Wednesday before your exam on Thursday. Although there's nothing really you're going to learn from this for the exam. Okay. So I'm going to hand this out. Please get to work on the assignment, the practice problems, which are on page 254. You're just using the quadratic formula. Again, though, everybody, briefly, if I give you, I don't have them here, so let me open it up. No problem here. These are all pretty straightforward. But if I give you something like 4c, I would switch the signs of everything to get a positive a value. If I give you something that has fractions, I would multiply both sides by numbers to get rid of those fractions. Try to arrange it so you have numbers that are integers, not